After we learned the some basic concepts about the probability, and we are going to learn the addition rule and the multiplication rule. So we do the addition rule first. Addition rule. Okay. And this addition rule, we're going to use this to find the probability of A or B. Okay, that's the probability that either the event A occurs or event B occurs, or both. So A or B or both. Okay, so that's or, and we the basic multiplication rule. The multiplication rule. Let me just put it here. Multiplication rule. The multiplication rule will be used to find the probability that A and B. Now you'll see some very important logic words, right? And, or, not, right? Okay, now first of all, let me introduce one concept. It's called a compound event. Compound event. That is the event combining two or more that contains two plus simple events. Do you remember what is a simple events? We just did that a little before. All right, now we're going to go back to the addition rule. What it says is this: P, A, or B. Okay. Equals probability of A occurs plus the probability that event B occurs minus the probability that A and B, which is the both. Okay, so this is the formal addition rule. This is the addition rule. Okay, in Venn diagram, we have like this is A, this is a B, and this is the total space. So A or B, that is A or B. All right, now if you look at this, which is the probability of A plus the probability of B, but since you count this area twice, so you're going to subtract it. That's the A and B. So in this little region, there's like an A and B part. So here's A and B. Okay. So A or B. A or B. Sometimes we write A union B. So it's just the notation. The other one, A and B, means both. That is A and B. So that's the two different notations that I hope you can get familiar with. Okay. Sometimes you might have something like this. You might have A here and a B here. There's no overlapping. Okay, in this case, the probability that A and B equals 0, because there's no way that both would occur, and we call this A and B a disjoint. Or there's another word. It's interesting. You have to remember that it's called a mutually exclusive. That means there's no and part, and in this case, if A and B are mutually if event A and B are mutually exclusive, then P A or B will be just the P of A plus P of B, because this and part, or the mutual part, is nothing. There's nothing in between, or there's no overlapping. So this is the addition rule for disjoint events. Okay, and for example, if A is, what is the probability that a randomly selected student was born in Virginia, and B is the event that a student was born in Maryland. So there's no way that someone can born in both states, right? You have to be either in Virginia or Maryland or other places. So they are like mutually exclusive event, and then we're looking for what is the probability that a student was either born in Virginia or Maryland. Then you just find each probability, add them up. Okay, and there is another thing. If you remember the A bar means not A, right? And we know PA plus PA bar, which is the probability of A, and the probability of not A, which is 1. All right, and A bar, they are mutually exclusive. Okay, so if you draw the picture, that's A, and outside is A bar. Okay, so that means there's really nothing. So someone either was born in Virginia or outside Virginia, and they are mutually exclusive. They are also complementary events, but they are mutually exclusive. There's nobody can be born in Virginia and at the same time not in Virginia, which is impossible. Okay, so that's a special case of the mutually exclusive, right? All right. Now there are a lot of application for this. Let me give you a quick example. This one, based on the survey, yeah, you see that we do the survey all the time. The probability of randomly selecting a household in the United States and getting one with a smartphone is 0.87. So probability of a smartphone equals 0.87. All right. Now, so if a household is randomly selected, can you find the probability of getting one that does not have smartphone? So can you find what is the probability that no smartphone? Okay. Since these two, they are mutually exclusive, they're also complementary, so the probability will add up to 1. If we have the probability of having a smartphone is 0.87, then the probability that no smartphone will be just 1 minus 0.87. So the chance will be 0.13, or the probability will be just 0.13. Okay, so that's fairly easy to understand when we talk about the addition rule. We're talking about OR, and then we have two events, A and B. So PA or B will be P of A plus P of B minus the mutual or overlapping part. And sometimes A and B, there's no overlapping. We call them mutually exclusive. And for an event and its complementary events, they are mutually exclusive events. Okay, so far that's everything we need to know about the addition rule. Now the multiplication rule. So that is P, A, and B, right? We already used that. And then what is that? That means that was probability that A occurs, then B occurs. That is A and B. One more thing we have to know is this P, B. There's a vertical bar, A. This is called a conditional probability. That is the probability that B occurs. Okay, B occurs given B given A, given, or we can just say assuming A already occurred. You see the difference between these two? This one is A occurs first, then B occurs second. All right, and then the probability that a B occurs given, okay, given that A already occurred. So that was the conditional probability. So let's we will use some example to talk about that. Okay, here. I think I have the this example here. Right. We are doing one test, and then we have a two-way table. All right. So here is the test result. I give you this one. Okay, give you this one. The test result. Test result positive and a negative. And for those people who actually, here's the actual, they use drugs. That's not a good thing. And those people uses drugs or do not, or use drugs. So they're not using drugs. Okay, so the number, so this is called a fact positive, and this is called a fact negative. Make sense? All right, and then I will put down the numbers and I will explain this to you. So 45, 5, 25, and 480. What does that mean? That means we want to find, you know, who is using drugs. We kind of know, you know, this is by fact. There are 45 people who are actually use drugs, and the test result comes out positive. Is that the correct answer? It is, right? So you test positive, and they are positive. So 45 is correct. That's good. What happened to these 5 people? They are using drugs. However, the test didn't find out. The test result come back as a negative. So those people kind of like a getaway, isn't it? So that's a 5. I always put the total. I just like to do it. So I always put the total. Now let's look at the second row. Those are the people who do not use drugs. However, there's still 25 people out of them come out with a positive test result. All right, and 480 of them come back with a negative. Actually, they're not using drug, and the test result found they're not using drug. So, however, like I said, I always like to put the total. So it's a 485. I just add the column, add the total. Okay, and all together, I have a 555 people. So that's my grand total. All right, so I got this. Let me ask you a question. What is the probability? Several questions. What is the probability that a randomly selected person who use drugs, randomly selected person who use drugs, and we all together we have 50 people who use drugs, and the answer is going to be 50 out of 555. Of course, you can simplify that. You get a 10 over 111. All right, now this is the probability that you randomly select a person who uses drugs. We are using the relative frequency approach to get the probability, isn't it? Okay, so that's the first one. That's the first question I have. And then let me ask you the second one. What is the probability that you choose the first guy test positive and second person test positive? All right, and I have a little note here. No replacement. Or we say without replacement. It's the same thing. Without. What about with replacement? So we look at these two situations. Replacement, okay. All right, okay. Now, a randomly selected person comes out. The first person tested positive. That's all the tested positive people. So that is a 70 over 555. Okay. When you see and, you're going to multiply. Okay. And the second person tested positive without replacement. The second person also tested positive but without replacement. Now think about, if you already choose the first person who is a positive, you put him aside. You're not putting him back to this 555. So how many people you have left? You have a 554. And how many people have a positive test result? 69. All right, then you're going to use calculator to find the answer. Let me get my calculator. So it's a 70 times 69. Numerator times numerator is a 4830, and the denominator is 555 times 554. So that is a 307470. All right, now 4830 divided by 307470, and the answer is 0.016. That's your probability. Okay, so this is without replacement. You find the first person who is positive, just put him aside, and then you go back to find what is the chance, or what is the probability that you find the second person tested positive. See, you -1 because that person get put out. All right, now what about a with replacement? Okay, then the probability that the first positive and the second positive test positive. So the first positive will be 70 over 555, and we know that. With replacement, that means after you find this person is positive, you put him back to the 555. So when you go back to choose the second person, the second subject, this person actually also have the chance to be selected. You are selecting 555. One out of this 555, and the total 70 of them test positive. Isn't it interesting? So that would be 4900 on top, and the denominator 555. Square is a 308,025. You see the numbers a little different, right? So that will be 490 divided by 308,025. Answer is 0.01. It's same, but this one is actually 0.015907779. So it's actually coming from here, right? But this one, 4830 divided by 307470, and that's coming from 0.0157088 496 and something. So when you round them up, it's 16, and here's a 16. But if you look at the next digit, here's a 9, here's a 7. So they're slightly different. Even they're very, very close, but they're different. So be very careful with this. And this is the multiplication rule. All right. Now, this guy, this one. This is the conditional probability. This is the probability that the second person tests positive. What's the chance the second person is positive, given or assuming the first person already tested, where the first person we found is already positive. So this is a conditional probability. Now, based on this, we can define this. The probability of A and B is actually the probability of A multiplied by the probability that B given A. You see that? So our example here, the probability of A, which is the probability that the first subject that we select randomly is testing positive, get the test result positive, multiplied by the probability that the second one is positive given the first one already happened, or the first one we already know that he tested positive. So that's why we're not selecting from 555, we're selecting from 554. Make sense? Okay. All right. Now, if we go to the second question I just have earlier, with replacement, what happened to that? If you put the first selected person back to the whole group, 555, right? And then you select the second one, which means whatever happened to the first person has nothing to do with your second person, the second selection or second result. In this case, if the probability that B given A is the same as the probability of B, then we call that A and B are independent of each other. Make sense? That's another important concept, right? Independent. All right, now let me give you another example. All right, now we're gonna look at all the students in my class. What is the probability that the first randomly selected two students, find the probability that they are born on the same day of the week? Okay, so you choose the first student. The first student was born on certain day. I don't care which day. Okay, and was born. I didn't write it. And the probability that the second and first on same day equals what? So the chance that the first person was born on a day, that's from Sunday to Saturday, is 1, right? Of course, he was born in one of those 7 days, right? Probably the first was born on a day is 1, and the second one and the first on the same day, that will be the given this. The first one already chosen, and the second one same day given the first one. So we already know what day the first one was born, and the second guy had the same day of birth. That would be 1/7. So the chance is 1/7. Therefore, that's the probability, right? The chance that two students are born on the same day of the week. All right. Now, what is the chance that they were not born on the same day of the week? That would be 1 minus this, so it will be 6/7. All right. Now, this is the question that what's the probability that they were born on the same day? Now, let me ask you another question. What is the probability that the first on Monday and second on Monday? What is this probability? When you see and, you're going to use multiply. So you're going to use multiplication rule. The first one was born on Monday, it's 1/7. What is the probability that the second one was born on Monday? Now you're going to ask yourself, are these two events independent of each other or not? Of course they are. So therefore, you just multiply by the second probability, 1/7. So the chance that they were born both on Monday will be 1/49. If they're independent, you just multiply. If they're not, then you have to use the conditional probability here. All right. Um, so I think that's all you know, all you need to know. Well, the good thing about this is um, the diffective rate. The let's see. Okay, now let me put it this way. What is the chance that you're going to win a game? All right. Now you the probability of a win equals, let's say you have 1/3 of the chance to win a game, and then the game repeats, and whatever happened in the second game, whether you win or not, has nothing to do with what your result for the first game. So what is the probability that you're going to win some money? 2 games. What is the probability that you're going to win game 1, game 2, or both? So how do you do that? The probability of a win something, it just means win something. And the probability of a win the first one, the probability of to win game 1, that's 1/3. The probability of a win game 2, is also 1/3. They're independent of each other. And what is the probability that you're going to win both? The probability that win 1 and 2, that will be 1/3 times 1/3, which is 1/9. You agree? Okay. And then when we talk about an or, and here is going to be the addition rule. So the probability of a win 1, win 2, or win both. That's or 1 or 2 or both. Do you remember the addition rule, which is the probability of win 1 plus the probability of win the game 2, subtract the probability of win both. Do you remember this? All right, that was the addition rule. So therefore that is 1/3 plus 1/3 minus 1/9, and we find the common denominator 9. So it's going to be 3 plus 3 minus 1, which is 5/9. Okay, so that is the probability that you're going to win something. Okay, either 1 or 2 or both. There's another way to do it. If you find the probability of a win equals 1/3, then the probability of loss will be 2/3, right? So what is the probability that you lost both? You lost 1 and lost 2. That's going to be 2/3 times 2/3, which is 4/9. This is a really bad luck. Okay, so you're not winning anything. So what is the opposite of it, or the complementary event of this, which means you win something? So the probability of a win something, 1 or 2 or both, right? So that's all that's all the win situation. Then there will be just 1 subtract this 4/9, which is 5/9. Do you see that we get exactly the same answer? Let me show you the previous page. We also have this. So the chance is the same. So either way, you can just go over this example, and then that might help you to understand a little bit more about the addition rule and multiplication rule.